Let me show you a modification that I make to the Fender TBX Tone Pot. So this is a stock Fender TBX Tone Pot, spline shaft. Actually has a nice length of threaded bushing for mounting. That's about the length of a, on their S1 switching pot, you have to buy the long shaft pot, which is considerably more expensive than the standard S1 to get that length. So it'd be nice if Fender just made them all that way. But that's the deal. So the nice thing about that is you can use this then on a guitar with a rear control cavity that's got like a 1/4 inch thick top. You can still use this TBX Tone Control, which is great because that's tends to be a lot of what I use these on. Now I've already got my cap. I'm using their stock 0.022 microfarad, the labeled 223, and I put a 1 meg resistor in parallel with that so that when you hit the, I set them up the way we'll get to that in a moment, but when I set it up, when you get to the center detent, it goes no load, and that kind of minimizes or eliminates the popping sound that you typically get with a no load pot when it goes open. So this modification is of no value if you're just going to use a standard Fender TBX Tone Pot and wire it the way that Fender does. What I'm doing is I'm doing a mod with this. I'm wiring it a different way. I'll go ahead and throw a JPEG into this video with my wiring configuration that I use, and what I end up with is the center detent position is actually a no load, and when you go counterclockwise from that, you roll the highs off, and when you turn it clockwise from center, it rolls the lows off, so you get high cut and low cut with one knob, and the center being no load. So I really like that with humbuckers, or if I've got a guitar with single coils where I've wired it so that the single coils are in series. That gives me the option to kind of thin that sound out a little bit, take some of the muddiness away, and it helps to make humbuckers sound a little more like single coils, but they're still humbuckers. So it's kind of a nice feature. I find it very useful in a lot of different situations. But there's one thing that doesn't work out perfectly for me in my application. Again, if you are just using it the normal way the Fender does and wiring it up, this mod is of no value to you. But I actually pass the signal through this I'm going to call it the bottom pot. It'd be the top pot if it's mounted and the knob is on it like you would normally have it configured when it's in the guitar. But when you're working on it, I tend to think of these things as the way that they are when you're working on the guitar, and it's upside down. The bottom pot here is the 1 meg. It's a logarithmic taper or audio taper pot. And what you will see here on the meter, what I do with my wiring is I'm actually passing the audio in through that onto terminal 1 and coming out off the wiper on terminal 2. And because of that, I would ideally like this thing to be 0 ohms from fully counterclockwise to the center detent. And what you're going to see on this pot is when I go to center detent, I'm at 939 ohms. So almost 1,000 ohms. So not a tremendous amount of resistance. That resistance is going to end up in series with the entire guitar signal all the time, the way I wire this. So that's not ideal. I don't know that it's a deal breaker if you don't want to go through this. You could certainly use it the way it is normally. I've done that with several of them. I've gone back since and modified them. But ideally what I want is I want that to be 0 ohms when it's fully counterclockwise, and I want it to stay 0 all the way to the center detent position. And then only start to come in with resistance when I come off of that center detent. Just for the purposes of showing it, I'll go ahead and show that it fully clockwise, this thing's 900 and some K. So it's close to the 1 meg that it's supposed to be. So here's what I'm going to do with this. I'm going to go ahead and take this apart. I can leave these guys on there. I've already put those on because I don't need to. Those can be connected for what I'm going to do. I'm only going to be dealing with this pot. I'm going to go ahead and pull these tabs back, open this thing up, and I'm going to use conductive paint and put some conductive paint on that resistive trace and make this thing close to 0 ohms from fully counterclockwise to the center. So I've gone ahead and pried up the little tabs that hold this in place. I've got several other videos with disassembly of these pots, so I'm not going to go through all that again, but I've pried those off. I'm going to take that threaded bushing off, that is the mounting threads, and then the resistive element that's inside the pot comes out from there. So what I'm going to do next, I've got some isopropyl alcohol. I'm just going to put some on a Q-tip, and I'm going to clean this surface. Just going to clean this up with a Q-tip, dry it with the other end, just to make sure there's no grease or oil on that trace so that the paint will stick to it. So when this is assembled and the wiper is fully counterclockwise, wiper is right there, which matches up with the wiper is right here on this end. Wiper is there, turning it clockwise. It's over on this end now. So that matches up with this side of the strip. So what I'm concerned with is I'm going to cover this side of the trace all the way to the center with silver conductive paint, and I'm just going to make this side a 0 ohm conductive strip all the way around. If you take this out, and there's obviously grease on the back side of it, so try not to get involved in that. If I take that out and set it down, then I can look exactly kind of where it lines up in the center, see how those fingers meet onto the trace, and I'm going to work from that, and I'm going to make sure that my conductive paint goes all the way to where those wiper fingers are when the knob is in the center detent position. So what I've determined after looking at that is there's this metal ring here that actually is the center conductive wiper. Right where that is, the two fingers of the wiper, there's one on the inside. There are actually two. There's one on the inside and one on the outside. So I'm actually going to do this at kind of a diagonal, and I'm going to work right off of that center area. Kind of the full thickness of that is kind of what's going to get covered. So I'm going to go right from there all the way back. Now what I'm going to use, this is the first thing that I've purchased. It's a pen, silver conductive paint in a pen. It actually has a tip that presses in. Probably no way you'll ever see that on here, but that tip presses in to release the paint. You kind of squeeze it as you work. It's got of course it's not going to do it now, but it's got a little ball or something inside of it, like a paint can would, so that you can shake it and it'll mix the paint inside there. I think when I'm done with this and I'm ready to get more, I'll probably just get one of those little syringes. Lots of sellers on eBay have the silver conductive paint in a little 10-gram syringe. This is 8.5 grams. That's probably an easier way to, in this particular application, I don't really need this pen. I just want to be able to lay down some of the paint. I typically just use a toothpick, a flat toothpick that I have here, to kind of smooth it and work with it once it's down, but I'm sure you could use little artist paint brushes, whatever you're used to or comfortable with. But I don't think this pen is really necessary. I think just the syringe with the paint in it would probably be just as well, or maybe easier to work with. If you do have one of these pens, one thing to just be aware of, just make sure you shake it until you hear that little ball slapping around inside there. And I do think you want to make sure you get it mixed. Overshake it, make sure you get it well mixed, because I did notice the first time I used it, I don't think I shook it enough, and the first stuff that came out didn't seem to have a lot of the silver particles in it. So just make sure you get that fully mixed. So all I'm doing is I'm kind of shaking it so that the ball is in the back, and then that's so I can squeeze on the tube. And I'm just kind of going through and applying it. I'm not going to shoot all of this, so I'm just going to go ahead and work on it, and then come back when I'm done. And now I've got the silver conductive paint all the way, well, not all the way, halfway around. That's my finished product. I'll let that, they say that you could use a hairdryer and cure that paint in 15 minutes or so. I'm in no hurry to get this going. I typically just let these things sit overnight, make sure they're good and dry, and then I'll check it with the meter and make sure that the conductivity is what I want. The only question really is the long-term durability of this with the wiper rubbing on that. I don't know. I have yet to take one apart after it's been in for a while, so you know that'll come over time. We'll see how this holds up to use. This time, one thing I did do, I actually didn't use the toothpick. I just used this plastic tip, and I used that to smooth the paint, and that actually worked a lot better than the toothpick because it's a nice smooth plastic surface that the paint doesn't really stick to, and that worked out really well for this. Okay, let's go ahead and finish this up. I've gone ahead and let this dry. I've also done one other thing that'll probably be very difficult to see on camera. It's not just covering the strip, the resistive strip with the conductive paint, but you also have to make sure you get a good connection to this solder lug here. So I've got a little bit of I made sure I made a good connection there. So now if I hook up the meter and measure from the solder lug, solder terminal to that center, I got about 1 ohm, a little less than 1 ohm there. So that's significantly better than what I had before. So I'm going to go ahead and reassemble this at this point. I've got my pot here. This wiper assembly is keyed, so there's only one way it goes in. One of those slots there is wider than the other, and so is its matching. You've got tabs and slots essentially, and they go together. So I will go ahead and put that in. The resistive element goes face down, so the conductive part is going to touch the wiper. You actually have another one there to look at, so it's pretty straightforward to see which way this is going to reassemble. And then my threaded mounting bushing drops over the top. There's nothing about that's unique. It's completely symmetrical, so it drops on either way, doesn't really matter. And then it's time to push the pins down, push the tabs down to hold it all back into place. You can do that by hand, or you can use a small needle nose pliers, which I don't seem to have within reach at the moment, but I'm just going to do this for now just to get it where I can test it. Now that I've got it reassembled, terminal 1 is the one, if it's oriented like this, like it were in place in the guitar and we were working on it upside down, terminal 1 is going to be this one on the right. So I'm going to connect one of my probes to there and the other one to the wiper, and with it fully counterclockwise, what you're seeing is there's less than 1 ohm of resistance, and then as I start to turn that, sorry, I had that at the center point. Okay, so now I'm fully counterclockwise and I've got 0.2 ohms. And as I turn this thing, it doesn't change. I hit the center detent, changes a little bit, and then as soon as I come off that center detent, I'm going to have to change my range. As soon as I come off that center detent, you start to see some resistance come in. We got 26K. What's the lowest I can get? There we go. Back at the center detent. As I just come off of that, you get the 1K, rises very quickly. I'll go up to the 4 meg scale, and you can see it goes right on up to 900K. So it's not quite a meg, but that's the pot we're dealing with. So in the center position now, it's a good solid 0 ohms, or pretty close to it. And it stays that way all the way to from counterclockwise to the center position.